Assalamualaikum and good day to Madam Irma. My name is Dayana binti Abdul Razak. I am from Group X and I will introduce my group members, which is Muhammad Shazwan bin Muhammad Syaiful Hizan, Nur Faradina binti Muhammad Khairul Faisul, and Safia Adibah binti Saiful Abras. Today, we are going to present the group assignment that consists of application questions. So, I will pass to the next member to start the presentation.
Okay, in this assignment, the genre of this assignment is we need to find or create two questions of the second order differential equation and solve the questions with one method from chapter 2 and one method from chapter 3. Okay, and after discussing with group members, we agree to choose one direct question and one application question. And this presentation, we will go through the two methods in solving application question. I will start with the question. Alright, the question given is a series circuit consists of a resistor with resistance 60 ohm, inductor 5 Henry, capacitance 4 millifarad, and 12 volt battery. Alright, if the initial charge and current are both zero, find the charge and current at time t. Alright, here is the solution. Okay, we are using the method from chapter 2, which is the method of undetermined coefficient. Okay, here is the equation given, general equation given, and then we need to insert the data from the equation into this equation, and then we get the new equation. Okay, next we need to find the general solution. Okay, before we find the general solution, we need to find the characteristic equation and get this characteristic equation. Okay, then we need to find the roots, and then we get the complex conjugate roots. So the general solution is this form. Okay, before we write the general solution, we need to define the value of A and B, and the value of A is -6 and B is 2, and insert into this general solution. So the general solution is given here. Alright, next we need to find the QP. Okay, as we can see here, the function is equal to 12 and there is no power at this 12, and then so the QP is A0. Okay, and then we need to differentiate QP twice, and then the both answer is 0. Okay, next, after we get this data, we need to insert back into this equation to find the QP. So the answer for QP is 3/50. So now we have QP and QH, and then sum of the QH and QP, and we get this answer.
Okay, now we want to look for the other part, which is on how we can get the constant value, which is A and B. So first we have know that the question given has given the initial value for the Q and the Q prime. So we substitute for the in this term, in this equation t equal to 0. So this t is t. A 0 and 0, and then we can get this. Okay, sign. We know that sign will be gone, so we can get A and this 3/50, and we can get for the A value. Done. So for the next is we have to differentiate for the Q. Yes, this Q, we have to differentiate this QT. So after we differentiate, we can get this equation, and then we substitute with 0, which is the t. We substitute with 0, and we know that sign will be 0. So we ignore that, and then we can get the 2b, and this 6 we expand, then we can get this -6a. So we substitute for the A value, and we can get for the B. Done. So after we get the A and B, we substitute back into the QT. This we can get this equation. So how we want to find the current, which is in RLC we have current. So this the charge. So this current, we know that we have to differentiate this QT. So if we differentiate, can get Q prime and negative 6 E T and negative 50 cos 2T I 50 sine 2T, and 3 over 5 will be 0 lah, and can get E T, and this term will be 3 over 5 sine 2T minus 9 over 25 cos 2T. Okay, now we solve it by expand this, expand here, and expand. So we can get 2 and 9 over 25. This for this negative 6 exponent negative 6t. So we can get the cos 2t same negative t and 27 5 sine 2t a t and plus 3 over 25 sine 2t minus 9 over 25 cos 2t. So here we can take a look at here. So this term will be cancelled, which is will be 0. So we can get 3 over 25 and this 27 over 25. So we solve this term. We can get 6 over 5 E 60 sine 2t, same like this. Okay, that's all. Thank you.
So this is the same questions that mentioned in chapter 2, and the method from chapter 3 we use to solve this question is the inverse Laplace transform. Actually this inverse Laplace transform has two parts, and I will explain the first part for the method. Okay, this is the equations that has also in chapter 2. It has the initial value which both of them is 0. So we can see here the highest power is 2. So we find the Laplace transform of DE that has power of 2. So it can be like this, 5 S kuasa 2 YS tolak S Y0 tolak Y kuasa 2 0 tambah 60 SYS tolak Y0 tambah 200 YS, dan kita Laplace transformkan yang nilai 12 ini. So daripada situ kita dapat 5 S kuasa 2 YS tambah 60 SYS tambah 200 YS sama dengan 12 per S. 12 per S kita dapat daripada menggunakan table of Laplace transform. Jadi kita boleh factorizekan nilai YS itu. At the end nya kita dapat persamaan YS iaitu sama dengan 12 per 5S S kuasa 2 tambah 12S tambah 40. Kita dapat nilai YS ini. So from that equations we can make the partial fraction decomposition that need to find the value of A, B and C. So we can darab silang the equations So we get the A darab S kuasa 2 tambah 12 tambah 40 tambah 5S tambah BS tambah C sama dengan 12. And from that equation we get the new one for the equation equal to 12. Jadinya daripada sini kita boleh tahu dan atau keluarkan nilai yang mempunyai S mengikut punca kuasa yang ada pada S itu. So kalau kita tengok sini, kalau S kuasa 2, yang ada S kuasa 2 pada persamaan itu adalah A dan 5B. Jadi kita tambahkan dia, jadikan satu persamaan. Dan kita dapat tahu nilai A sama dengan negatif 5B. So next kita tengok S yang ada kuasa 1, iaitu 12A dan 5C. Dan 12A itu adalah A itu kita boleh gunakan pada nilai yang ada pada S kuasa 2. So kita masukkan nilai A iaitu negatif 5B dalam persamaan ini. Jadi kita dapat S kuasa 2 S kuasa 1 yang persamaan dia adalah negatif 60B tambah 5C sama dengan 0. Jadi yang tinggal terakhir S yang tak ada kuasa iaitu 40A dan 12. So kita direct daripada situ boleh dapat nilai A yang sebenarnya, iaitu 3/10 daripada S yang tak ada kuasa ini. Jadinya daripada situ nilai A yang kita dapat, kita boleh cari nilai B yang sebenar menggunakan equations yang ada pada S kuasa 2 ini. Jadinya 3/10 sama dengan negatif 5B. Jadi kita bawa dia ke bawah, iaitu dapat jadi bahagi. So the value of B is negatif 3/50. Seterusnya bila dapat nilai B iaitu negatif 3/50, kita masukkan dalam persamaan negatif 60 B tambah 5C sama dengan 0. Jadi B itu nilai B kita dah dapat, so kita masukkan dalam persamaan ini. So kita at the end-nya kita dapat nilai C yang sebenar ialah negatif 18/25. Jadi kita dapat nilai A iaitu 3/10, B negatif 3/50 dan C negatif 18/25. So that's all for me. I will pass to the next member to proceed the part 2, the last part solution for the inverse Laplace transform to see the same answer as mentioned in chapter 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Faradina binti Muhammad Khairul Faisal. Today I will continue the step from chapter 3. As you know, my friend has explained it a little bit about how to use the inverse Laplace transform. So we will insert the given initial value condition and rearrange the algebra equation to give the transform of the solution. So for the next step, I will be present how to solve the method inverse Laplace transform when we know the unknown of A, B and C. When we know the value of A equal to 3/10, B equal to minus 3/50 and C equal to minus 18/25. So I invert the answer in the formula which is A per 5S plus BS plus C divided by S power of 2 plus 12S plus 14. After that, we use the inverse Laplace transform using the table of Laplace transform to find the value of 3/10 divided by 5S and inverse Laplace transform of negative 3/50S minus 80/25 divided by S power of 2 plus s plus 14. Before that, I will find the inverse Laplace transform for 3/10 divided by 5s. And when I refer to the table of Laplace transform, I will get the answer is 1/s. I will subtract 3/10 in front and then multiply by 50. And the answer of inverse Laplace transform for 3 divide by 10 multiply by 5s is equal to 3/50. For the next solution of the inverse Laplace transform, we use the first shifting property for the equation. If we equate the formula for the first shifting property with the inverse Laplace equation above, we can know that f s minus a is equal to negative 3/50s minus 80/25 divided by s plus 6 power of 2 plus 4 and equal to exponent power of negative 60. But before that, we have to find the alpha. That the alpha is equal to negative 6 and the gs will become g s plus 6. Then we replace s with s plus 6 and negative s at the top and keep s plus 6 at the bottom, and we will get the equation like negative 3/50x minus 9/25 and divide by s power of 2 plus 4. So after that, we know the value of gt equal to inverse Laplace negative 3/50s minus 9/25 divided by s power of 2 plus 4. The equation I will get when we expand the above equation and replace s plus 6 with the original s. The last step, we can find the inverse Laplace of negative 3/50s minus 9/25 divided by s power of 2 plus 4. So for the last step, I break down into two different equations and remove negative 3/50 for the first equation and negative 9/25 for the second equation. So in the equation has only s power of 2 plus 4 and 1/s power of 2 plus 4 will remain. So based on the table of the Laplace transform, we will get the final answer. The final answer is negative 3 divided by 50 cos 2t minus 9 divided by 50 sin 2t and multiply by exponent power of negative 6t. So that's all for my group, and thank you.